Good evening, everyone. I welcome you all in a Sapience Education. For more information, please visit our website www.sapienceeducation.com. So today I'm going to discuss about the oscillation chapter part 1 oscillation. Okay. So what is actually oscillation? Let us to understand the oscillation before we need to understand what is periodic motion. Any motion which repeats itself after regular interval of time is called a periodic motion or a harmonic motion. Okay. Any motion which repeat itself after a regular interval of time, which let us see the example. Let us see an example. There is a sun, and Earth is revolving around the sun or at a regular interval of time, and it is being repeated. So that's the periodic motion. Okay. Or you can also consider any other motion like a pendulum motion. So where when you just lift this pendulum, so what will happen, it will try to go and repeat its motion from one end to another at a regular interval of time. So this type of motion is called as periodic motion. Now let us consider what is time period. The constant interval of time after which the motion is repeated is called time period. For example, let us consider here, this is the earth, and earth takes 365 to complete one oscillation, means one complete oscillation. After that it will repeat itself. So the time period is your 365 days. Now let us consider about the pendulum also. Let us consider the bob starts its motion from this end to this end, and again it end come to its initial position. So the time required to go from here to here and here to here is, let us take as 4 seconds. So the time period that is denoted by capital P is written as 4 seconds. Okay. Now example, motion of a planet around the sun is the periodic motion. Motion of the pendulum of the wall clock is the periodic motion. I hope you have understood now. Now what is frequency? Number of oscillation complete in 1 second. For example, if any object is moving, or you can see beside there is a figure or figure, see here, uh, motion is being repeated at a regular interval of time. Motion is being repeated at a regular interval of time. So the time required, for example, 4 seconds. So how many round 4 seconds it requires to complete one oscillation? It means that how many oscillation it completes within 1 second. In 1 second it will complete only 1 by 4. So 1 by 4 is your frequency, that is 0.25. Let us consider in 1 second it completes 2 times. So the frequency will be 2 hertz. So frequency is definitely denoted by F is equal to 1 by T, and the unit will become hertz. So by this formula we can derive directly the frequency. Okay. So these are the oscillatory motion or periodic motion from a figure. We can understand how this motion is being repeated at regular interval of time. So all these things are periodic motion. Now, apart from periodic motion, we need to know what is oscillatory motion. The motion of a body is said to be oscillatory or vibratory motion if it moves back and forth or to and fro about a fixed point after a regular interval of time. Back and forth. For example, if we consider Earth is being moving around the sun, so it is not back and forth motion. But when we talk about the spring mass system, so what will happen, if there is a mass and if you displace this mass from this direction or this direction, what will happen, this mass will sometime it will come in this direction, and after some time you will able to see that this mass is in this direction. But one thing is common is that they both are or this mass is creating a to and fro motion. So if it is creating a to and fro motion, then what is happening here? What is happening here? At every time, what will happen? A force will always act opposing to it. So this type of motion is called as a oscillatory motion. Or we can say the vibratory motion is also a oscillatory motion. Why? Because the in vibration, what happens? It will go to and fro motion, right? It will come to the to and fro motion. It is also a vibratory motion. So oscillatory motion or oscillation is where wherever we see a to and fro motion or back and forth motion, then that motion is known as oscillatory motion. And you know that oscillatory motion is also a periodic motion. Why? Because its motion is repeated. But Earth is moving around the sun, so the this motion is periodic, but it is not as such oscillatory motion because it is not moving back and forth or to and fro. Now let us see the simple harmonic motion. It is the same as oscillatory motion. Oscillatory motion. So it is the type of periodic motion in which particles moves to and fro about a mean position is called simple harmonic motion. So simple harmonic motion is also known as oscillatory motion. So whenever we talk about simple harmonic motion, so it means that there is a to and fro motion. So from figure, what do we consider from figure? So this red color one is a S.H.M because it is back and forth motion. But when we talk about this Earth is moving around the sun or a round trip, so it is not S.H.M. It is not S.H.M. I hope you have understood now. Now from here we can understand that how to and fro motion happens. Now from here you can see that when we apply a force on this spring mass system, so what will happen? See what actually happens. There are two type of force. One is forward and one is backward. So the backward force always act toward the mean position. When we talk about toward mean position, let us see here. This is the mean position, and this object will always try to come toward the mean position. So this is the example of simple harmonic motion. I hope you have understood now, right? So I hope you have understood now about S.H.M. Now here we can see that there is a spring mass system, and it has been displaced. It has been displaced from its mean position. So let us consider this is a mean position. So what will happen if I will displace from its mean position, or or we can also say that hmm, this green color is a normal or mean position of an object where we haven't put any type of energy. After that, what will happen if we apply a force? So it will happen, this object will come to this position. But at the same time, what will happen? There will be an external force acting on this object toward its mean position. This force is known as restoring force. Restoring force, which will be applied by, which will be applied by spring. So it will always try to make it in try to pull the object toward the mean position. Okay, and this type of motion is known as S.H.M. Now in S.H.M, what happens? In S.H.M, particle always moves toward the mean position such that acceleration of an object is always proportional to the displacement but in a negative direction. So the more displacement will be there, the more acceleration will be there. So from here figure we see that acceleration of a body is directly proportional to the displacement, and it is in a negative. Why? Because acceleration is opposing in nature. Acceleration is opposing. Why the acceleration is opposing? See here, when I pull this object toward this direction, right direction, so what will happen? A spring is just spring is creating a force in leftward direction. So due to this there is an acceleration. So acceleration is always toward the all opposite to the displacement. So if displacement is at a right side, so the acceleration will be at a left side. Okay, so I hope you have understood now. So finally we can write here that acceleration is directly proportional to the negative of displacement. Okay, now let us find a general equation. This is a general equation like this. General equation, x into t is equal to a cos omega t plus phi. Okay, at a t what happened? X at a t, let us consider the displacement of an object is x, and a is the amplitude, and this one is the phase, and omega is the angular frequency, and phi is the phase constant. So this is the general equation of the S.H.M. So whenever we want S.H.M, so S.H.M has the formula a sine omega t or cos. We can use the sine as well as, okay. Why we are using sine or cos? Because what happened? It is to and fro motion. When we see the graph of the uh, when we see the graph of sine and a cos wave, see here. So what happened? An object is going upside as well as after certain time it is coming upside. So what is actually happened? This is to and fro motion. So to and fro motion. So as we know that S.H.M is a to and fro motion. So if S.H.M is a to and fro motion, so we can use this, right? So S.H.M is to and fro motion. That's why we need to use this equation. X is equal to a sine omega t plus phi or a cos omega t plus phi. I hope you have understood now, right? I hope you have understood now. Now let us give an example. Omega is our angular frequency. This is equal to distance by time. As we know that in a circular motion, the total length covered is 2 pi, and the time taken to complete one circular motion is a t. So finally, omega, that is your angular velocity, and this can also be written as 2 pi by T or 2 pi by V, where V is a frequency, nu, or V, not V, we can say nu. Nu is also known as frequency. Okay. Now let us consider what is phase. It represents the state of the particle, that is the position direction of the motion. See here, in which phase? Phase means what? Which position the particle is at. For example, if we draw the curve of a sine curve or S.H.M curve, so particle may be at this position, may be at this position. So it depends upon the time. See here, it is time dependent as well as the velocity in angular velocity dependence. Okay, so this is the phase. So phase tell us the situation of the particle, position and direction of the motion. Now what is phase constant? It is the initial position of the particle is not the mean position of the maximum displacement. Then the phase constant phi is added to the displacement of the equation. Yeah, let us see here. Let us see. If there is no phase, so what will happen? A particle is simply moving like this. So let us consider particle displacement is equal to x is equal to a sine omega t plus phi. If it starts from initial position, so what will happen? The graph will start from here on. But sometimes what happens? Its position changes. For example, it may start from here. So if it start from here, so what will happen? To complete one oscillation, it has to go like this. So it means that it is in a phase. It means that it has an initial phase, and that phase is known as pi by 2. Why pi by 2? Because this is 0, this is pi by 2, this is pi. When a wave start from this position, so the phase become pi. So I hope you have understood the phase constant. So this is a phase constant. So it is the initial position of the particle, which is not the mean position of the maximum displacement A. Then the phase constant phi is added to the displacement of the equation. So here x is equal to A cos omega t plus phi. Phi is a phase constant, or x can be written as A sin omega t plus minus phi. Okay, I hope you have understood now. Now in case of linear motion, what happens here? X is equal to ut plus half gt square. So here x is a time dependent. Okay, in case of periodic displacement also, it is a time dependent. If time stops, then no periodic motion will happen. So periodic motion is fully a time dependent. So in periodic motion, so x can be written as A cos omega t, or x can be written as A sin omega t. But the thing is that if wave starts from initial position, then only we can write this equation. But wave may start from here. Wave may start from advance only. Wave may start from here only, or wave may start from here only. But we don't know. We don't know from where the wave starts. So how to differentiate this wave? By using phi constant. If phi is minus phi, so it will start from here. If it is plus phi, so it may be start from here, any point. So to complete this displacement equation, so we have to use x is equal to A cos omega t plus phi. So this is the general equation. Now, what is restoring force? Restoring force, it is the force acting on a particle executing S.H.M that tries to bring the particle back toward the mean position. If you have seen the diagram, or if you have seen the GIF or anything, see here, this object trying to move forward, but due to restoring force, it again goes up. So every time what happen in S.H.M, it will always move toward the mean position. It will always move toward the mean position. I hope you have understood now. So when it will try to move toward the mean position, it means that the force is acting just to oppose the motion. So if it is the force acting on a particle executing S.H.M tries to bring the particle back toward the mean position, it means that force is always proportional to x, but in a negative way. So force can be written as F is equal to minus k into x. Now where, okay, so k can be written as m into omega square. So finally force can be written as F is equal to minus m omega square into x. Now what is amplitude? It is the magnitude of the maximum displacement of the particle in either direction. Let us consider you have to draw the graph like this and like this. So if we talk about amplitude, is the maximum displacement in either direction, either upward or downward. So let us consider, I hope you have understood that this is one is the maximum displacement, either this one is the maximum displacement. So this maximum displacement is known as amplitude. This maximum displacement is known as amplitude. I hope you have understood now, right? Now graph of x is equal to A sin omega t, x is equal to minus A cos omega t. So here we can draw a graph like this only. So these are the, basically you have to use a sine graph. So this is a sine graph, and if you want a cos graph, just start from top like this. Why so? Because at t is equal to 0, so or t is equal to 0, so what happens? Cos is the maximum velocity, that is maximum amplitude. So we can use any type of graph. Now let us consider any periodic motion function can be expressed as a function of a sine as well as cosine with the different time period. Okay, a simple periodic function fn is given by ft, which is the function of a time, because periodic function it is the based on the time, so that can be written as a cos omega t. If omega t can be increased by integral multiple by 2 pi, then the time will be capital T, and the value for the function will remain same. Why same? See here. From figure you need to understand why I'm telling this. It is the same. Let us consider this is the graph, okay? This is the sine graph, right? So uh, all, or we can also draw the cos graph only. Let us use here, because the function is a cos, so I can use here cos graph. So let us consider the cos function is behaving, or the graph is behaving like this, okay? So this is 0, this is a pi, this is a sorry g, this is 0, this is pi by 2, this is the 3 pi by 2, and this is 2 pi, right? 2 pi. Now, if omega t can be increased by integral multiples of 2 pi, if I will multiply it by 2 pi, what will happen? Let us consider, the function ft as a value 1, 1 at this place at 0. When you multiply it by 2 pi, then also see here the value of the amplitude will be 1 only. When you multiply it by 4, again 2 pi, that is 4 pi. So suppose this is a 2 pi, and this is also 4 pi. So when you multiply it by 2 pi again, the value will remain same. It means that, and 2 pi is what? 2 pi means what? It completes one cycle. So the time period will be capital T. So it means that if an argument omega t can be increased by integral multiple of 2 pi, then the time will be t only, and the value for the function will be same. See here, value for the is your maximum displacement only. So value for either 0, 2 pi, 4 pi, 6 pi will remain same. So since time period is equal to 2 pi by omega, so function, let us consider if a ft was a function, can we write ft is equal to ft plus capital T? Why so? Because at t plus capital T, I just now have showed you that at this is a, let us consider this is the value. When I add this capital T, means one complete more cycle, so the value of either it may be maximum displacement, either it may be maximum displacement, or it may be the displacement. So the value will remain same after time capital T. So ft, let us consider ft is can also be considered as a sine omega t. If I will consider ft as a sine omega t, similarly ft can be written as a sine omega t plus b cos omega t. Why so? Because sine, either you can use sine as well as cos, and if you add a different trigonometric function with the same angular frequency, then there is a no change in the function. Okay, so we can write a sine omega t plus b cos omega t if I have taken function ft as a sine omega t, or we can tell function as a b cos omega t. Okay, so this type of two function can be taken. So put the if this put the value, let us consider a is equal to d cos phi. If we put a value a is equal to d cos phi and b is equal to d sin phi, then we can easily put here ft as a d cos phi into sin omega t and d sin phi cos omega t. Now a cos theta sin theta, cos theta sin phi plus sin theta cos phi. It means that the formula can be finally written as d sin omega t plus phi. So the function, from here we can see that the function, there is no changes because it is still omega t. The only changes is the phi only. So phi is a phase change, but the behavior of the graph won't change. Why? Because the omega t is not changing. Graph may start from here also. The pattern of graph frequency will remain same. Now what about d? Since we need to find the value of d as well as phi. See, a function ft is equal to d sine omega t plus phi is given, right? So what about d? Now as we know that we have considered a is equal to d cos phi. Let us consider a is equal to d cos phi and b is equal to d sine phi. Now if we square both the side, what will happen? A square is equal to d square cos square phi and b square is equal to d square sine square phi. Now add this both, so what will happen? A square plus b square is equal to d square cos square phi plus sine square phi. So as we know that this is a 1, so d can be written as root under a square plus b square. So finally we have got the value of d. Now let us consider what is the value of phi. Why? Because we need phi. We need, if we want to combine the functions, so we need d. So we have arrived the formula d. Now let us find the value of phi. So how you will find a phi? So as we divide this equation, let us consider this is equation 1 and this is equation 2. So if we divide two equation by 1, so what we will get? D sine phi divided by d cos phi, this is equal to b by a. So tan phi is equal to b by a, or we can say phi is equal to tan inverse b by a. I hope you have understood now, right? So this is the method to find or combine the equation of having a two function like a sin omega t plus b cos omega t. So just we can add this function to create a new function, and the new function has a value of a d sin omega t plus phi. And you see that the frequency, angular frequency should be same. Then only we can add it. Now let us do some of the question. Here we can see that harmonic oscillation is represented by x is equal to 0.3534 cos 3000 t and 0.74 t, where x is in mm and t is in second. Calculate the amplitude. So if we talk about amplitude, so can we compare this equation by this? X is equal to a cos omega t plus phi. So from here amplitude A is equal to, we can write 0.34 mm. So we have got the amplitude, the answer for amplitude. Now let us consider frequency and angular frequency. So angular frequency is what? Omega. So omega is equal to what? Here we should compare this. So we compare, then the omega will be equal to 3000 only. Okay. Now angular frequency we have got. Then frequency is equal to what? So as we know that omega is equal to 2 pi by t, 2 pi by t or 2 pi into frequency. So frequency is equal to omega by 2 pi. So here omega is equal to 3000 divided by 2 pi. So this will be 1500 divided by pi is the angular velocity. So I hope you have understood now. Omega, sorry, this is the frequency only. Sorry, this is the frequency. So frequency, finally we have got frequency is equal to 1500 divided by pi. I hope you have understood this now. So angular frequency, the frequency you have got. What is period? Period is the time period only. So how you will find time period? So time period is equal to 1 by f only. So f you have got 1500 by pi. So here 1 by 1500 divided by pi. So finally time period is equal to pi by 1500 we have got. So I hope you have understood now this. This one we have understood. Now initial phase, that is phi. So how we will find phi? So phi is what? See here, compare this equation. Compare this equations phi and to this one phi. So phi is equal to 0.74 radian. So finally phi can be written as 0.74 radian. I hope you have understood this all concept, right? So one more question we can do here. A particle execute a S.H.M of an amplitude of 25 centimeter. Okay, and the time period is how much? 3 seconds. What is the minimum time required for the particle to move between 2 points of 12.5 centimeter either side of the mean position? So what they have given, before that we need to understand what they have given. So they have given amplitude or time period. So time period they have given how much? 3 seconds. And amplitude, they have amplitude means maximum displacement, they have given 25 centimeter, right? Now they want the time, that is small t, is equal to how much when x is equal to 12.5 centimeter, or the time between the two oscillation to and fro. Okay, so let us consider this is the and mean position, and the displacement is x they have given, right? So how we will find? So first of all we have to find a general equation. X is equal to, general equation x is equal to a sine omega t plus phi, right? This is the general equation. Okay, let us consider here phi is equal to 0. So x is how much? X is 12.5 centimeter, and amplitude, maximum amplitude is 25 centimeter, into sine omega t plus phi. So we don't have a phi, so let us consider phi is 0. So what is the value of omega t? Okay, let us consider now omega is equal to 2 pi by t. So from here we can find omega is equal to 2 pi by t, and 2 pi by capital T is given how much? 3. So 2 pi by 3. So can we write here 25 into sine 2 pi by 3 into time period, and this is equal to 12.5. Now just 12.5 divided by 25. So this is 12.5 divided by 25, and this is equal to sine 2 pi by 3 into time t. Now this is half only. So from next half is equal to, that is 1 by 2 is equal to sine 2 pi by 3 into time t. We need time t is equal to what? Okay, so sine, this is sine what? 30 degree only. Half means what? Sine 30 or pi by 6 is equal to half. So here we can write, in place of half we can write sine pi by 6. If we put sine pi by 6 and sine 2 pi by 3 into time t, so from here we can see that this must be equal, then only both the sine function is equal. It means that pi by 6 is equal to 2 pi by 3 into time. Pi by got cancel out, so this will be 3 1 is 3, 3 2 is 6. So the time is equal to 1 by 4 only, that is equal to 0.25 second. This is the time for traveling one side displacement, that is 12.5. So the time t1, time for right side is how much? Right side is 0.25. But they are asking the time required to come for the particle to move between 2 points, that is left side also, that is the extreme position. So between 12.5. So one side also 12.5 and another side also 12.5. So the time required to move between minus 12.5 to plus 12.5 is equal to 2t, that is equal to 2 into 0.25. So finally this is 0.5 second. So this is the final answer. So I hope you have understood this well. Okay, so I will hope I have able to explain the oscillation. So I will meet you in the next classes, next part, to complete all the things. Okay, thank you.